Okay. We're going to learn about something called synthetic division in a minute here. But I want to wrap the discussion on long division up with one of the characteristics of it that makes it useful. Because here's what is inevitably going to happen: you're going to see synthetic division, and you're going to like it a lot better than long division, right? I mean, look at this process. Oh, sorry, wrong one. Look at this process. This is painful. Synthetic division is a little bit simpler. Okay. But what we can do with long division, there's one thing we can do with long division that we can't with synthetic, and we'll talk about it a little bit more later. But one of them is this. So say I have this polynomial, this cubic polynomial here, and I have these two factors for this. Okay. Now, if you look at this cubic polynomial here, and you were like, well, I can factor this. They want to know all of the factors, right? Well, I can factor this by grouping. Okay, I'll spoil the ending for you. It won't work. Okay, so we have two factors, but if I multiply these two factors together, the best I'm going to get, and we can do this real quick off to the side, okay, I'm going to get x squared, right? Well, this is x cubed. So what do I need? I need to be able to multiply this times another factor that has an x in it in order to get this x cubed term, right? And this is something we're going to learn about again in the future called the fundamental theorem of algebra. But in order to get to x cubed, I need to have three x's, right? I need to have x times x times x. Well, in this case, I only have x times x. So what we can do with long division is we can say, okay, now we've done a couple examples where we've divided a polynomial function by one factor. How do we divide it by two factors? When we're doing long division, we do that by multiplying these together first and then doing long division with this, okay? And it's going to look awful, but it actually goes pretty quick. So we're dividing by their product, okay, when we set this up. And we'll learn a different method later on, but for now, we're going to stick with this, okay? So the process doesn't change. We still only look at this first term when we're trying to decide what we multiply by and what goes up here, okay? What do I multiply x squared by to get x cubed? And the answer to that is x. So I write the x above the x term. Then I take the x, I multiply it times x squared, I multiply the x times negative 5x, and I multiply the x times 4. Okay, and then I subtract. Now this is, again, I'll emphasize this is negative 2 minus negative 5. Negative 2 minus negative 5 is really negative 2 plus 5, which is 3. So I have 3x squared here. And this is negative 11 minus positive 4. So that's really negative 11 minus 4, which is negative 15x. Okay. Then we come back and we say, what do I multiply x squared by to get 3x squared? And the answer there is 3. So we put a 3 here. 3 times x squared is 3x squared. 3 times negative 5x is negative 15x. And 3 times positive 4 is positive 12. So we're really just adding an extra term to this process, but the process for doing long division doesn't change. And I think you see what's going to happen here, right? These x terms are going to cancel. Negative 15 minus a negative 15 is negative 15 plus 15, which is 0, and 12 minus 12 is 0. Okay, so here's our remainder, okay? We have no remainder, and no remainder, just remember again, means that this is the missing factor, right? We know that this times this is going to produce this value, okay? So we can say here at the very end, you've got two ways of saying this, right? We can say that when we did this division, the result of dividing this by the x minus 1 and the x minus 4, the result of that division was just x plus 3, right? Just relaying what the quotient is. Or a different way of expressing it is saying that because I do that division and I get this as the answer, this is the missing factor in this product. Okay, I can multiply that by those other two factors and get this, right? So this is the product of linear factors that we want when we're looking at something like that. We had to do division to get that third one, okay?